Okay, this last video for sure, feel free to just kind of scroll ahead and check your answers as you go. I'll just kind of speak my thought process as I go through each one. In case you get stuck, you can go back and hear what I'm saying, but I wouldn't expect most of you to watch this one all the way through. Okay, so try them. Let's see how it goes. First one I'm doing is neon. I know it's going to be 10 electrons, so 1s2, 2s2, 2p6. We jump into 3s2, and then we're going to get 3. Oh, I just overshot that, so just kidding. Let's see, I'm stressing people out right now. No, it's not that one. Sorry, because you're not listening to me, which is okay, but then I messed it up. 2p6 is where we stop with neon. I just overdrove that one. I was so excited to get going, but here it is at the 2p, and it's the last one there. Germanium, then, we're trying to get to element number 32. Looks like it's going to end at 4p2 is what I can see from where it's at. It's in the 4p area, and it's the second one in. So 1s2, 2s2, 2p6, 3s2. You can be looking at your periodic table, eventually just kind of know it. 3p6, and then we go down to 4s2, 3d10. Oh boy, we're running out of room here. And then it's going to be 4p2. Can I fit that in there without having to squeeze? There we go. 4p2. Okay, tin. Tin is a weird one. If you don't know its symbol, it is SN. It's element number 50. So here it is, and it's hanging out in the 5p block, the second one there. So I'm going to have to write small for this one. We're at 1s2, 2s2, 2p6, 3s2, 3p6, and then I'm here right now, right? And I'm like, oh, what's next? Okay, well, I just look. 4s2, and then we jump into 3d10. I've just got here, okay, and now I'm going to have to go through the whole 4p, so it's helpful to remember that 4p is going to have 6, but if I don't remember, I just count 1, 2, 3, 4, 5, 6. Now I'm to the 5s2, takes care of those ones. 4d10, looks like it's going to be all of that, and then we're going to end up in the 5p2. Okay, cool. Lanthanum. Man, my hand was already hurting. Lanthanum's way down here in the lanthanides in the F block. The tricky thing about lanthanum is that you have to remember to, when you get here, to jump down to the 4F, and then after the 4F, you come up to the 5D. Okay, so it's a little bit funky. The D orbitals and the F orbitals kind of lag behind the S and the P orbitals. Okay, so lanthanum, same old, 1s2, 2s2, 2p6, 3s2. Do you see how I start to memorize after a while? 3p6, 4s2, 3d10. I'm literally just writing tins again. I'm not even thinking about it too much, hoping that I did that one right. 5s2, because I have to get at least to 10, and then it's going to start getting lucky. 5s2, 4d10. Now in the 5p, I'm going to do all 6 of those. That gets me to here, okay? Now I'm down to the 6s. I'm running out of room, so I'm just going to come underneath here. 6s2, that gets me to barium. Now I have to jump down here and do the 4f, but it's just the first one in the 4f, so it's going to be 4f1 to end that one. Okay, now I'm going to tell you something that's going to throw off the people that are just watching this, that technically that last one actually ends up being 5D1. If you were to look up the electron configuration for lanthanum, this is an exception to the rule. There's kind of this phenomenon where this 4f orbital really collapses if there's only one electron in it, so it ends up being more stable to jump up here. However, if you put 4f1 for our intents and purposes, it's okay for now. I just want you to be aware that as we get bigger and we start including that f orbital, it gets a little bit funky. Okay, and then let's do our last one here then, iridium. So iridium is going to be the same thing as what we had before. You know what I'm going to teach you real quick because I'm getting sick of writing these. It's something called a noble gas shortcut. If you want to use it, you sure can. Basically, you go to the noble gas, which is here, the one closest to the element you're going to, and you just say, hey, it's going to be that one. So like for iridium, it's going to be the same as the electron configuration for xenon. So sorry if you're just watching and now having to listen to me. I lied a little bit. Same as electron configuration for xenon, and then I want to tack on just a little bit more. So everything from xenon, and then 6s2. Okay, so that takes care of here. Now we're trying to get all the way to iridium. Well, we have to go through 57 to 70, so that's going to be this whole F block here. 4F14, and then we come back up and we have to do 1, 2, 3, 4, 5, 6, 7 in the 5D block, which you can hardly see anymore because I've just written all over it. So 5D7. So that would be a way to write the electron configuration for iridium. You could write out the whole thing like we did before, which maybe for those just watching and not listening, I'm just gonna circle this, and I'm gonna bring that down here. We could do the same thing except at the very end here, instead of ending here, we could put the 4F14 and the 5D7. Okay, both of these are equally good. This is just called a noble gas shortcut for when we're writing these really long ones. Xenon's electron configuration is this whole thing, and so this is replacing that whole xenon piece. So you can write it out, or you can write the noble gas. It just has to be the one like right before it. So like if I was doing nickel, I'd write argon in brackets and then fill up with whatever's left over. Okay, it's okay if you don't know how to do that, but if you want to, go for it.